All right, so what we're going to do today is look at roots. Okay, we've found roots by looking at factorising in the past. So we're going to actually look at roots in a slightly different way and see what we can apply. Just on the face-to-face lesson is scheduled for next Wednesday. I'm just actually inquiring whether we're allowed to continue to do it and whether the other schools are still going to send their students and so forth. So as soon as I know more, I'll let you know. All right. So let's talk about finding square roots to start with, and then we'll branch off. So we're just going to start with square roots. So if I asked you to do that calculation on the board, reasonably simply and quickly, you could give me a solution. Yeah. What is it? 5, right? So we can get an answer really quick, and we can go, that's 5. Okay, so that's fine. And we get 8, and how many answers are there to the square root of 25? No, it's just 1. There's only 1. It wasn't a trick question. There's only 1 answer, right? However, if I ask you this question and ask you to solve that, how many answers are there? There are 2, right? And so you would solve that and you get x is equal to plus or minus 25. 5, sorry, plus or minus 5. So why are there 2 answers in the second example? Why? That's not what, I didn't say what, I said why. Why are there 2 answers? Maybe? Why are there 2 answers? Both work is a reasonable answer, yeah. Why else might there be? What did you say? Okay. If we sketch that function, what does it look? What kind of function is it? Or what kind of equation is it? It's a parabola, so it's a quadratic, right? Which graph has a parabola, right? How many solutions are there to parabolas? Up to 2. Okay, so for all those reasons, yes, because both numbers work, but it's a parabola, which means it's got 2 roots. Okay, so we've got the 2 ideas and we've got 2 solutions. And that's all fine and dandy. But what if we start to look in the complex plane? Okay, now we identify complex numbers as being z. Okay, so a complex number is z. And how do we define z? Yeah, so it's got a real part, which we're going to call A, and it's got a complex part, which we're going to call B. Okay, what you're doing is up there. Okay, and then I'll come over and help you in a few minutes if you need to answer questions, right? So we've got a complex number A plus BI. So what if I asked you to say, all right, well, what if I asked you to solve this question? Let's say it was solve that. So how many roots do you expect there to be? How many sorts, possible answers for z do you expect there to be? 1, 2, 2, 2. Do you want to change or do you want to stay solid?
1.
Why 1?
Because everyone else was 2.
Why, yeah, okay. Yeah, okay. So why were there 2 in this form? Right? So if it's a squared, if we want to find this, we're basically finding the roots of a quadratic still. Even though the quadratic is not now in x, it's in z. So we're going to solve that. So we're going to look at 2 different ways of solving that problem today. Okay, which will lead us into, okay, if we can find the square root of a complex number, can we find a higher root of a complex number? A cubed and fourth and so forth. Okay, so let's look at the square root to start with. So we're going to solve this using our Cartesian form to start with. Okay, so in Cartesian or rectangular form, so we've already identified that z is equal to a plus bi. So is it okay to say that that is a plus bi squared, and that must equal 3 minus 4i? So is it reasonable to say we actually want to find the value of z? If we have that z squared is equal to 3 minus 4i and we're asked to solve it, which I didn't write, I should do, then we actually want to know what the value of z is. And we think there are two values. Okay? And the form that it's going to take is a plus bi. Now we don't know what a and b are. One might be 0, one might be, if they're both 0, we're in trouble. Alright? But we're going to try and solve it. So any thoughts about how we might start? How might we start solving that problem? What would you do first? Yeah. Okay, how will that help you in any way? Okay, so that's one thought, but I don't think it'll help you. All right, so what else could we do? Pardon? Expand the brackets. Okay, so if you expand the brackets, what are you going to get? So left-hand side, expand the brackets.
Oh,
You're grade
Yeah,
12.
yeah, yeah,
You
yeah,
should
yeah.
not be doing that anymore. Then A squared plus 2ab minus b squared. So remember, we're trying to find a value for z. So in other words, we're trying to find a and b. Okay. So if we expand a plus bi all squared, a plus bi times a plus bi, using your crab claw or whatever method you want, foil, it simplifies to that.
Why
Why is it minus b squared? Because I squared is 1, negative 1. You want to go with that?
Yeah.
Okay, so what do you think I might do now? Remember, we're trying to find a and b. We've done questions like this before from this point on. Pardon? Good. Why? Good. So if we think about our real and imaginary parts of a complex number, they never mix. Right? You can't combine them together and make it into a single one term. They'll always be separate. So therefore, if we've got a squared minus b squared as real terms on the left-hand side, then those two combined must equal 3 because there's an equal sign here. Right? Similarly, the complex part, or the imaginary part, apologies, wrong word, the imaginary part, the 2ab on this side must equal negative 4. Otherwise, those two sides of the equation can't equal each other. Okay? So I've got a squared minus b squared is 3, and 2ab is equal to negative 4. I don't need the i's because I've just identified the real parts and the imaginary parts. And we've done things like that before. Right? Get the real parts and the imaginary parts separated. So what do I have now? No, I don't. Simultaneous equations. Remember, my goal is in this case is not to factorise, it's to solve. Right? So I've got simultaneous equations. Okay, have I got enough equations to solve this? Yeah, why? 2 variables, 2 equations. Okay, so which method of solving am I going to use probably in this situation? Substitution. Okay, because it's easier. So I'm going to rearrange the second equation. So just divide both sides by 2a to get the b by itself. Okay, so b is negative 2 over a. And then I'm going to substitute that back into the first equation. So I'll do that now. So therefore a squared minus negative 2 on a squared is equal to, what am I doing here, over equals negative 4.
Three.
Oh, 3, sorry, yes it is, 3. Thank you, good pickup, so it's equal to 3. Now the algebra fun part starts. We're going to solve for A. So let's just get rid of those brackets on the second term. So we're going to have a squared minus 4 over a squared is equal to 3. How am I going to solve that?
Factors. Or bring the A to the top. Factors.
Bring the a to the top. Can you be... What,
8 squared. Bring it up from the upper to the new amount. Yeah, so make it A to the negative 4, A to the negative 2.
no.
No.
No. No, that will just make it way... Oh. Okay. Yeah, you could, but it just makes the next 4 steps really hard. You can do it easier. There's an easier way of doing it. So yes, you could do that, but it's just going to take us longer to get to the solution, all right? So I'm just going to say no, okay? So it's not wrong, but just there's a better way.
Get rid of the fraction by making the a squared negative now.
That's exactly what he said.
Okay.
Yep.
I thought it was like
But I do like when you said get rid of the fraction. But just not... So what do you notice? Or actually, I'm just going to rephrase that. It's not just the get rid of the fraction. I just like the fact that you said fraction.
So that's better than 1.
Yeah. So the first term would be a squared over 1, right? So if we make them both into fractions, what are we doing with those two fractions? What's the operation in the middle of the two? What's this thing? Subtraction. So I'm subtracting fractions, don't I? If I subtract fractions, what do I need? Common denominators. What's my common denominator? A squared. Do you agree it's a squared? So my left-hand side is not going to... Well, if I need to make them both over a squared, well, the minus 4 is already over a squared. Right, but what does the other term become?
And A.
A and 4, yeah. Equals 3.
Then just get one there.
It'd be nice if that was the case, but goodness me, no.
Oh, no, because it'll fall
Okay, any thoughts from here? What's the most annoying thing there? No. Well, really? Okay. There's a few more annoying things to me than that, but okay, what's the most annoying thing about that solving? It's still a fraction, yeah? But it's all over a squared.
A.
So what can I do with the a squared in the denominator?
Bring it.
Move to the other side. Don't bring it to the top, take it to the other side of the equation. The whole reason that we go from that to that to that is to move the a squared over there. All right, I can't move it until it's a single term. Okay, and then I'm just going to go through, oopsie, no I'm not. So then I'm going to make it all on the same side. And we end up with that. What do we kind of have sort of like, so a little bit kind of sort of? Quadratic. Kind of.
Quartic.
Except it's 4, 2 and 0 rather than 2, 1 and 0. But it still follows the same patterns. So I'm looking for a factors of negative 4 that add to give negative 3. Any ideas? Factors of negative 4 that add to give negative 3.
One.
negative 4, negative 2, and negative 1. Not right.
I'm so glad you stopped. Yep. Factors of negative.
Three
So,
negative 1, sorry.
well, 3 times negative 1 is not negative 4.
No.
So,
Negative 4.
what are my factors of 4?
Negative
1 and 4, and 2 and 2, right? They're my factors of 4. 1 and 4, 2 and 2. Yes? So So I want them to combine to give -3. Well, it has to be 1 and -4. Because 2 and 2 won't ever give me 3. So I'm going to have a to the 4. Sorry, no, it won't be. So that factorises like that. Okay, let's just pause there for a second because it's taking way longer than I wanted. You okay at that point? So therefore, now, what does that tell me? I've got to solve for A, correct? So which one do I choose, or do I choose both?
You want B in that.
So if I solve that, how do I solve it, by the way? What's the rule? Null factor law. Yep, so the null factor law, once again, there it is. Okay, so I've got a squared minus 4 equals 0. So a squared equals 4. So what's a equal to? Plus or minus 2. One day I'm going to get that as an automatic response. I'm not holding my breath, however. What if I did the other term? A squared plus 1 equals 0. Now, can we actually solve that? Yeah, we can. However, do we need to? Okay, let's go back and examine what it is we're actually trying to find here. We go right back to the top. What are we trying to find? A and B, right? Tell me about A. It's real. It's the real component. I'm 100% correct. It's the real component. Now, if I find this solution here, is A real? No. Okay, so just repeating that. If I find that solution, it's going to have an I in it, which means A is not real, which means that solution is not relevant to this calculation because A needs to be real, because we define it to be real by putting it there. Cool? If I was solving for B here, so if I decided to make A equals -4 over 2B and solve for B, I would be solving this one, not this one. Because B's got to be the imaginary component. Does that make sense? No, it doesn't, Tyler, does it? Because you're looking at me like I've got 3 heads. Can you see I've got 2 possible solutions here for A?
Yep.
You okay to that point? I can solve both of them. This will become A equals plus or minus I. Right? Now, the problem then is, well, that means that A has to be imaginary, but it's not. It's real. So that can't be a solution. So we're going to leave it out because A is an element of the real numbers because we defined it to be earlier. That's the only reason. So now we've decided that A is plus or minus 2. Therefore, what's B equal to? Okay, so when A is equal to +2, B is equal to what? -1. And can you just inform everyone else how you got that? You're right. How'd you get it?
I subbed it into the original that.
Yeah, the equation that says B equals. That's the hint. There's an equation that says B equals -2 over 8. So when A is equal to -2, what's B equal to? 1. So therefore, Z is equal to 2 minus I or -2 plus I. I might write the whole Z equals. No, -2 plus I. So we solved for it, we found our roots. So the square root of 3 minus 4i is 2 minus I or -2 plus I. So what that means is, if I get 2 minus I, and I square it and expand it and simplify and collect like terms, etc., I'm going to get 3 minus 4i. Similarly, if I get negative 2 plus I, and I square it, and then expand and simplify, just like we did like in this process here, when I do it, going from there to there, right, I'll get 3 minus 4i. I'll get the same answer. Okay, so these are my solutions. Now, if you were to sketch those on the Argand diagram, right, so if you just sketch those two solutions for me. So where's 2 minus I and where's negative 2 plus I? Can you just sketch those 2 points for me on the Argand diagram? Correct. So, what did you see? Just put them on the same diagram, so I should have been more clear. Sorry, put them on the same diagram. That was my fault. So 2 minus I, so 2 minus I would mean it's down here. Yes? So we do a line, there's that point. And where's negative 2 plus I? There. And so we come out here. Now, do we notice that in the whole Argand diagram there are 2 roots, and how far apart, what's the angle between them? 180 degrees. So remember that Argand diagram is all the way around, so the circle, right? And we can keep, it's just like every other, like when we did trig functions and we have the circle, all right? This is the same idea. Okay, so we can see that when we have a square root, we find a square root across the complex plane, we'll get 2 solutions, and those 2 solutions will be 180 degrees apart. Okay, because it's 360 divided by 2, which is 180. Okay, so that's one way of solving those, and that was very heavily algebraic, and you're all sitting there going, well, that's just nasty. Right? So what is it? There must be a different way of doing it. Mustn't there? Because that's just yuck. And if I asked you to do a cubic, you'd kill me. Right? It was bad enough trying to make you expand a square, let alone a cube. And then if we go x to the z to the 6, which we're going to do later, you're going to go, oh, right? So that's just not fine. So there must be a better way. So what do we look at in polar form? Okay? What if we express ourselves in polar form and see what happens? So if you recall, our problem is that z squared is equal to 3 minus 4i. So could I please ask you to then take that form, that expression, and express the 3 minus 4i in polar form? So the r cis theta form. Okay, so this is a good practice as well, because you need to be able to do this under exam. You want to get these guinea marks, express a complex number in polar form. It's the same way as you do it for a vector. sake of today, let's work this thing in degrees. But if you want to put it in radians, I don't care either. It's not going to be a perfect angle. All right, so we can work it in whatever form you prefer. All right, have you done it in degrees or in radians? What have you sort of defaulted to? In both. What did you guys end up doing? Degrees or radians? Degrees, yep. So what did you get? 53?
Something around.
Maybe. Yeah. That's important. Yeah. It's very important, but it is important. You said 53 bricks.
Negative 53.1. Yeah? Okay. So that's negative 53.1 degree. Okay. So again, if we were to draw that, all right, we'd be 3 units across and 4 units down, so we'd be down here somewhere. Okay. So it'd be 5 negative 53.1. Okay, using our principal argument. We could express that as a positive value, it really doesn't matter. Okay. But for the sake of this, we'll just leave it like that just for the moment. See what happens. Okay, so we can rewrite this now as z squared is equal to 5 cis 53.1 degrees. Okay. Okay. Any any ideas where we might go with this? Do we know any rules or any applications? What if I rewrite z? Now remember last time we said z was a plus bi, but in polar form would it be r cis theta?
R cis squared theta. All squared.
So it's 5 compared to 2 times.
Yeah. So if we were to solve this, right, the left-hand side, r cis theta all squared, we could use whose theorem to simplify that? De Moivre's. Yep, and I can't say it properly either. But fortunately, on your exam, you're not assessed on pronunciation. Okay, and we know that his theorem says that r cis theta to the power of n is r to the n cis n theta. Is that okay? So if we expand the left-hand side then, so we've got r cis theta squared, that's going to be r squared cis 2 theta. Agree with that? Alrighty. I'll just rewrite that line because it just came out a bit horrible. It's going to come out worse if I write it like that. So that's De Moivre's theorem. So basically what we've got is r squared cis 2 theta has to equal 5 cis negative 53.1. So the same idea as before, we're trying to solve for r and theta in this case. Last time we were trying to solve for a and b. Okay? So how do I solve this then? What's the matter? And what did you do?
I just did it straight into the equation.
What equation?
Like the 5 cis.
You substitute that in something? What do you mean to straight into the equation? Because you're not squaring 5 cis theta, you're trying to find the square root of it. Because we're trying to find, we're moving the square to the other side. So effectively we're going to solve r squared equals 5. Yes? So we're going to solve the two equations just like we did last time. So r squared has to equal 5. And 2 theta has to equal negative 53.1. We're going to come back to that because there's more to it than just that. And hopefully when you're solving from using our trig functions, which have the same one, because this is a trig function, it's cis, cos and I sine, right? We need to do something with that, but we'll come back to that in just a minute. So we've got r squared equals 5, so what's r equal to? Yep, 2 seconds for me. 273. Good, mate. Yeah. Yeah. Says that there won't be any unit for last year. There haven't been. What are you trying to find the curriculum? Oh, just grounded middle school for the moment. Yeah, but yeah, thanks mate. Cheers. All right. So, therefore, now normally what would we write as an answer? We'd write what as a solution here? What? Plus or minus root 5. That would be normally the case, is that correct? But in this context, what does r represent? The distance from the origin. So in this context, we don't worry about the negative 1. We take the principal square root. Okay? So does that make sense? Because r is just how far am I from the origin. The angle is determined by theta. So the direction, I should say, not the angle. The direction is determined by theta. So even though the correct solution to r squared equals 5 is that r is equal to plus or minus root 5, we're just going to take r as being root 5. Okay? So therefore, as r is a... I don't use the term scalar because it's a distance, and we're all familiar with the term scalar because we've all done vectors, right? Then, or it's a magnitude if you like, because it's the size of the distance. Therefore, r is equal to root 5. Okay, so we've solved one. So now we're going to solve the other guy. All right, now, what we need to think about is this. Pardon me. If you remember from when we used in Caskell, we were solving trig functions back in methods a little while ago, okay? We needed to take into situation the fact that on an Argand diagram, all right, so we've got our 53.1 here, so that might be this angle here, okay? So we've got that angle, and we can go there, and then we could also go to there and get the same value. And we could go like that and so on and so forth, right? So what we need to remember here is that 2 theta is not just the minus 53.1, and we can go in both directions, by the way, but we can also go, it's minus 53.1 plus some multiple, I don't know why I've written 2, some multiple of, and because we're in degrees, that's why it's 360. Okay? Now, the other thing you've got to think about here is that because we're using a negative angle, right? So if we were looking at a positive angle, we'd go positive and then around again. But if you think about this one, so if I was to go around once, what would be the size of that angle? So if I was to go from the origin, or from the x-axis, or the real axis, around once and then down to 53.1, it would be negative 53.1 minus another 360, wouldn't it? Yeah? So we're actually going to subtract in this case, because we're at a negative angle. If it was if this was a positive angle, then we would be adding multiples of 360. Okay? Now, what does the n represent? Can you remember from our trig stuff? How many times around the circle I've gone? So if I go nonce around the circle, then I'm just going straight to that angle. So when n equals 0. If I go once, I've gone around once, and then I go back to there. Now, if we're doing the square root, so in other words, 2 theta, I only need to worry about n equals 0 and n equals 1. Because that'll give me my 2 solutions. Because how many solutions do I expect to be? 2. Right? If there was 3 theta, so if I was doing r cubed, for example, then I would go n equals 0, n equals 1, and n equals 2 to give me my three solutions. Why are we doing what?
Why does the r squared and r cubed?
Because it tells me how many roots I need. In other words, it tells me how many times around the circle I need to go to get all three, or all two, or all one. Show me. Okay, so this is we did this in trig. We covered this already at quite a deal. So I'm just going to come down here where there's a bit more space. Okay, so therefore I want theta. Okay, now remember we're using quite ugly numbers because I made this question up. Sometimes it'll be a lot nicer than this. So if I want to find theta, what do I need to do with the right hand side? Divide everything by 2. Yeah, it's not hard. Yep. Okay, so minus 53.1 minus 360n all divided by 2. Now you can simplify and divide both sides by 2 and that's fine. Perfectly okay. Okay, so what happens when n is equal to 0? In other words, the very first root that I find when I go around. So what's theta equal to when n equals 0? 26.05? No, 26.55. Theta is going to be negative 53.1 minus 0 over 2. Because 360 times 0 is 0, right? Which is 23.55 degrees. Correct? Am I right? Right? 33, yep. So that gives me my first value for theta. Okay? What about n equals 1? Theta is going to be minus 53.1 minus 360 times 1, which is 360, over 2 equals. Whoop, that should be a negative sign. Apologies for that. Drop the negative sign out. What is it? 26.55. Good to see. Is it 26.55?
Yeah.
Yep, beautiful. Okay, thanks for the correction. Okay, what will the next one be? Sorry, can you say it again for me?
Negative
0.55. Yep, okay. All right, so are we okay to that point? Okay, let's just recap very quickly how we got our... Yes, go.
I just wanted to know how you figured out how many laps.
Well, I could keep going. Okay, let me show you what happens. So I've chosen n equals 0 and n equals 1 because I'm doing z squared. So twice. Right? I do two choices. If I was doing z cubed, I'd go n equals 0, n equals 1, n equals 2. So to the fourth would be n equals 0, 1, 2, and 3 because it gives me 4 roots. The power on the original question tells me how many roots I want. But if I did go again, let's say I just didn't realise that, and I went again. What would that equal then now? So that'll be negative 53.1 minus 360 by 2 over 2.
Oh, it's more than just a 40.
Yeah, but even so, what is it?
It makes negative 386.55.
Negative 386.55. So, Adam, to continue to finish your question then. Adam, can we see that's our first value? Tell me how that value and that value are related. How far apart are those two? Keep going. That one and that one. That's 386.
Oh, is that an 8?
That's an 8, yes. How far apart are they? 300 and 60.
Yes.
They're 360 degrees apart. And 360 degrees is how far? Full circle. So we've just come back to where we started. So if I keep going, you'll just come back to one of your original that you've already calculated. So that's the second way we know how to stop. Right? But the easier way is, if I'm finding the square root, I want 2, 0, 1. If I've got the cube root, I want 0, 1, 2, and so on. Cool? So I don't need that solution. It was just to prove that I could stop there. So therefore, r cis theta, whoops, psst. Right? So, my z value. So therefore z is going to equal root 5 cis negative 26.55 or root 5, oh, I might write the whole thing. Girls, shh. Now, let's talk about this minus 206.55. Right? So if I was to draw that minus 206.55, what quadrant are we in? We're in the second quadrant, aren't we? So if I was to write minus 206, that's all the way around there. So if we have an angle in the second quadrant, do I express it as a positive term or a negative term? If in the second quadrant. So if I have an angle, if I have a position in this quadrant, I'm supposed to do it as, remember the principal arguments? So I should really express that as a positive angle. So if that's minus 206.55, what's this angle left here? Yep, calculator's out. Can someone just confirm that? 153.45. Yes, I did say that. He said that. Yes. Cool. So there's my two solutions. Now, my question to you is this. If I just make this small enough so you can see it. Yep, I apologise, I know how tiny it is. So can we see here that we've got two solutions? 2 minus I and negative 2 plus I. And we've got root 5 cis that and root 5 cis that. Are they the same thing?
And we can test it, but they will be.
Yeah, exactly right. We could test it and we could prove that it's the same. So we've got two ways of solving those things. And for square roots, it doesn't really matter which process you follow. Whether you do it in Cartesian form, by using the algebra, or you use de Moivre's theorem and solve it that way. But we can see, hopefully, that by taking the square root of a complex number, we've got two solutions. Okay? And they're 180 degrees apart. If I was to give you a cubed root, right? If I was to give you a cubed root, how many solutions do you expect to see? How far apart should they be angles-wise? 120 degrees apart. And if you think about the theta part, right? So we do it in radians this time. Okay? So we think about, we're going to get to the point where we've got 3 theta is equal to some angle that we've calculated before, right? Plus 2 pi n, I'll put it that way. 2 pi n, right? Because we start off with our, so if we go back to the previous screen, back here, we started with, right? We had 2 theta from our de Moivre's theorem expansion, right? Was our angle that we calculated. And in this case, because it was a negative, we went subtracting because we're going that way, minus a full rotation times an integer, 0, 1, 2, right? When we're in radians, right, it's whatever angle we calculate, so using our net tan minus 1, blah, 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 right? Okay, in this case, it might be a bit simpler than that, we'll see. So it's some angle plus some multiple of 2 pi, which is a full circle in radians. Okay, now, if I then go to theta, what's my next step? Well, it's going to be whatever that angle is divided by 3, plus 2 pi over 3 times that multiplier. And how many degrees is 2 pi and 3? 120. All right? So that's where the 120 comes from. Because they've got to be evenly spaced, 120 degrees apart. So that's all this is. So when n equals 0, that'll just be the first angle. When n equals 1, it'll be that angle plus 120 degrees. And then when n equals 2, it'll be that angle plus 240 degrees. Boom, boom, boom. And we get our 3 around the corner. So what I'd like you to try and do is have a go at that one using De Moivre's theorem. So Z cubed. How many solutions should you get? 3.
3.
Yes, that's right. Yes, I knew you'd broken a finger in the felt one. Right? So have a go. Convert 1 into cis theta form. I know you're all sitting there going, yep, we're right with you. Choose, oh, you want to get a drink or something? Okay. So if we were to write the number 1 in cis theta form, what would it be? Okay, so here's a real trick question. Where is, if I wanted to plot the number 1 on my Argand diagram, where would it be? It's just over here, wouldn't it? So what's R? And what's my angle? 0. I just wrote theta. So my angle is 0. And it's used, and we need it there because this will be 0. That will be 0. So 0 plus 120, 0 plus 240. So it's not going to be that challenging. Okay? So, see if you can come up with your 3 roots. And when you've had a go at that one, then really test yourself and do that one. But it's not really a test because it's the same type thing. Okay, so try the Z cubed, and then there's, if you scroll across, it's Z, another Z squared one. I've got 2 questions on there for you to have a go at. Okay, so solve the first one, Z cubed 1, and then solve Z cubed equals 2 plus 3i. Alright, have a practice of those, and then we'll go through the solutions in a few minutes' time. So I might change this question just to make life a bit simpler. I'm not trying to make it difficult, right? So let's just make it 1. That should give you a nice exact number. Yes, let's make that 1 plus. Is that okay?
Yeah.
I've just changed this. Oh. There. So what I've done, sorry about that, is I've changed that to a 1. Just makes your angle nicer. It's good practice for using radians. All right? And then once you've done that, I'm just going to add some questions for you to have a crack at while I go and work with these 2. You. Yeah, you. Yeah, you just thought you were getting the whole lesson for it, but no.
Actually, I was kind of on my side.
Good. I like that. Oh, I like those questions. Okay, so we've got, what I'd like you to have a go at is those questions there, once you've had a go at those. I'll go through the solutions with you in a minute, but those are a bit of questions I want you to work on. So try and solve those two. I'll come and check on you in a few minutes' time. So what's one way to check your answers?
Check my pick.
Draw them. Draw them. So draw them on a Cartesian plane. If they're exactly like, look like they should be, 120 degrees apart, you're probably going to be right. Okay? But you can always sketch it.